So this is Algebra 1, Semester 2. It's a unit called Inequalities Review. It's the unit number 6, and it's a lesson solving inequalities with multiplication division practice, which is lesson number 4. It's on CreatorMath.com under the Algebra 1 tab. You might have to Google CreatorMath.weebly.com to find the actual website. The instructions to this problem set are: copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from CreatorMath.com. I always try to show how to find those notes because it can be difficult. Hopefully once you find them once, you can always get back to the notes, you guys. But just in case, I go over it every time. All right, the name of this website is CreatorMath.weebly.com. Google that. If you do, hopefully you find this homepage. It looks like this. If you have any questions about the composition book, just scroll down, find the words composition book here, and read all the directions, you guys. Watch all the videos, adhere to the turn-in dates, and put things on the pages where they belong. Then look to the tab of the class, and there are 5 things basically under the tab to the class. It is the notes, okay, that's one thing, and the problem set, like we're going to go over now, the video of how to do the problem set, which we're making now, the page numbers on which the notes go in your composition book, and the all-important vocabulary practice study PDF, which is a complete list of all the vocabulary we use for the entire semester. It is downloadable to your device, and it is searchable. Just Google, how do I search a PDF with whatever type of device you're using, and follow those directions. It's a little bit different per device. Next, we're going to find the semester we're in, so go to semester. Under that will be the table of contents. This is very important, so important that I ask you to write the entire table of contents on the pages 2 through 6 of your composition book. Why? Because it's got all the page numbers here for everything, where everything goes the entire semester. And I find that once students write it in, now their comp book looks like a champ. If not, they have no idea what's going on for the rest of the semester, right? So if you haven't written this in already, please stop what you're doing and write this table of contents into your composition book on pages 2 through 6. Please watch the videos on the following page to see how to number your pages / what a great composition book looks like. Okay, now let's go to the unit. This is Inequalities Review. And let's go to the lesson. The lesson we're talking about is number 4 in this case. So right here, solving inequalities with multiplication division. Here are the page numbers on which the notes go. Please don't take this video's word for it, but go back and find the original table of contents. At the time you're watching this, these page numbers likely will have changed. The notes aren't linked right now, but they will be, so you'll be able to click right here to get notes. The problem set we're doing is linked right here, and the video solution, if everything goes well, will be linked right here. With that said, let's try to do the problems for this lesson. They start out very easy in review. This symbol is a greater than. This symbol is a less than. Right? We've been over these a bunch. This is a greater than or equal to. This is a less than or equal to. On a number line, what's an open dot means? It means the value is excluded. Right? If this is a -2, this is a 0, and there's an open dot, and everything's going off to the right, this is excluded if it's open. It is not included. Excluded is the opposite of included. So we would say here x is greater than -2, but no equals, because it does not include 2, or -2. All right, let's see what else they've got for us. How about a solid dot? What does that mean? So same situation, say we're on -2, and it's now a solid dot. Right here, 0, and it's going off this way forever. So in this case, the solid dot means the number is included. The value is included, right? So we would write x is greater than or equal to -2 to show that equal to includes the value 2. What's a parentheses mean? This is set notation, means the value is excluded. Right? What does a bracket mean? It means it is included. So in set notation, the parentheses and the bracket are the equivalent of the open dot and the closed dot. So say you have a set between, let's do -2 and 5. There's a 0 somewhere in here, and say this one is open and this one is closed, right? So this would be x is greater than -2, and x is less than or equal to 5. Why is this equal to? Because it's a solid dot. How do you write that with the brackets and the parentheses? Well, this would be -2 is the lower value, and it's not included, so use a parentheses, comma, the bracket is, the 5 is included, so use a bracket. The notation, set notation, completely different from a coordinate point, you guys, is a set notation. This says it's going from -2, not including the value because it's a parentheses, and a bracket, including 5 because it's a bracket. All right, and we use, this would be a inequality notation, this would be a set notation. All right, how's this read? Positive infinity. How's this read? Negative infinity. If there is one, there is the other. There's a 0. Off to the right's positive infinity. Off to the left's negative infinity. Well, easy cake. Just to understand, a lot of books won't write positive infinity. I like to write it because if a student knows there's a positive infinity, you know, like right here, it's just written infinity, right? But if you literally write, oh, it's going to positive infinity, students will get the clue. Whoa, if there's a positive infinity, there must also be a negative infinity. And that sort of helps their brain just get to the next step. Because we always start talking about positive infinity, but of course, now you're going to go a little bit further, talking about the other. Is infinity a number? No. Infinity is a concept that numbers either increase or decrease in the form of negative infinity forever. So, a billion is a number, right? It's not a concept, it's a number. But infinity is not a billion. What if you go to 2 billion, right? That's not infinity. What about 20 billion? That's not infinity, etc. Right? You get the idea. So infinity, the idea that something increases or decreases forever, is a concept. Solve the following inequality. All right, here's what we've got. We've got 14 is greater than or equal to x divided by 4. We're going to multiply both sides by 4. The 4's cancel. X is less than or equal. What's 4 times 14? Would be 40 plus 16, 56, I think. Now we're going to flip it. Flip it and flip the sign also. Okay, the 56 here, the x here, but don't forget, this thing must literally rotate. That's what a flip is, right? So the small less than side's toward the x, it still is less than x after being flipped. So x is less than or equal to 56. Here you go. All right, let's go to the next. 9x is less than or equal to -90 divided by 9 divided by 9. X is less than or equal to -10. X is less than or equal to -10. Now that reminds me, they're also putting it into set notation. So if x is less than or equal to -10, start with the -10 and it's equal to, so you need a bracket, a comma, and then it's less than, so it's going back toward negative infinity forever, which is not a number, so parentheses. So parentheses, negative infinity, comma, 10, bracket. It's 2 answers, which means, let's look at this, if it's less than or equal to 56, you've got a 56 with a bracket because it's included and it goes backwards to negative infinity forever, so parentheses, negative infinity, comma, 56, bracket. 2 answers. Okay, all right, let's go to the next. Negative x over 9 is less than -10. Okay, so couple things here. Let's multiply both sides by 9. Gone. Negative x is less than -90, right? Now let's do this. Let's add x to both sides. And let's add 90 to both sides. Right? This makes the 90 disappear. You get an x over here. The symbol still stays the same. And this is x minus x. You get a 90 over here. Let's flip it. X is greater than 90. Okay, so it's this here. And it's a set notation of x greater than 90 means 90 is not included, comma, plus infinity, both parentheses. Parentheses on this side because infinity is not a number. Parentheses on this side because the 90 is not included. It's greater than 90, right? So parentheses 90, comma, plus infinity. Now, we being math teachers, start to take shortcuts at some point, and we like them, and it messes up students on some level. But, I don't know, it just makes things easier. Let's do this again. Let's take -x divided by 9 and rewrite it, okay? There's an old rule that if you just go ahead and either divide both sides by a negative or multiply both sides by a negative, you flip the sign. So because we did all this way is valid. Just go through and watch the video again if you don't get it, right? But if we multiply both sides by -9 in this case, and this side by -9, when multiplying by a negative, this sign must flip. Must flip. Okay, so negative times negative is positive. The 9's disappear. This becomes the x stays on this side, and this becomes negative times negative is a positive 90. X is greater than 90. See it right here? X is greater than 90. X is greater than 90. Yeah, we just start to, I don't know. It's too much work to do the whole thing long form every time. And you see what happens here. You see the rationale for the flipping. Why does it flip? Because you had to add this negative x to both sides, right? And this negative 90 you had to add to both sides. So what happened was the sign stayed the same here, and the terms flipped from their side by adding to both sides, right? Here we just took a shortcut. And because we were multiplying or dividing by a negative, we just flipped the sign and we get the same answer. It would also be, this would be the same set notation. I'm going to probably use, if I multiply or divide by a negative from here on out, I'm just going to flip the sign, you guys. Okay. Make sure you're matching up the title of this video with the problem set you're doing, otherwise it's not going to make much sense. This is Algebra 1, Semester 2. It is a unit called Inequalities Review, number 6, and it is a lesson called Solving Inequalities with Multiplication Division Practice, and it's lesson number 4 under that unit. It's on CreatorMath.com under the Algebra 1 tab. Hope this helps.